Thank you. Good morning, and thanks for the opportunity to be here and to talk about interesting, intriguing link between nature and humans. And at the end, this is actually our main problem: how to combine human needs and natural needs at the same time. And so far, we have discussed a lot of technologies, a lot of solutions, and actually there are solutions, but the humans are an important element of this discussion. And so this is why we should explore more these relations and vulnerabilities. Both humans and nature have their vulnerabilities, and anything we do in the future has to take into account that. I will start from this slide showing basically interesting paradigm of the past that was with the human development since maybe 50 years ago. On the left, you see a nice painting from the Etruscan tombs near Tarquinia, near Rome. And this image shows a very grateful image of people with agriculture, so looking at the fruit of the soils and the food, and they have a kind of respect and thanking the nature giving the food to them. Are we thanking our agriculture? Are we thanking our soils today as humans? I don't think so. We are not thanking our soils. We are trying to push as much out of our land. We are trying to put a lot of pressure on our soils, and so it's changed a lot. And on the right side, you see also another image coming from the forest, and you feel the fears. You see people scared to walk inside the forest. Are we scared to walk inside the forest today anymore? No. We go everywhere. We cut every tree we want. We don't have any problem to reach any place in the world and use the natural resources. So we are now in the moment where we have to rethink about our relations with our needs and with the nature as well. And I think Pope Francesco gave a very important contribution with the Laudato Si in thinking and proposing this idea of the common house. We are all together inside. That's, I think, a very strong message. Okay, yeah, this is another image that also I illustrate for this concept of where as humans, we don't have any fears and we are everywhere. The first panel showed the flights, the routes that are crossing all over the world. In space, we don't have any limitations anymore. We go everywhere in our planet. And the bottom panel is showing a timing problem, is the daily contacts of Facebook we can have today. So the social also, we are really, all of us in contacts. And this is, of course, a positive, but at the same time, it can create vulnerabilities as well. So, yeah, population is, of course, one of the dramatic change we have faced in the last 50 years. I was born in 1959, for example. You see the great increase of population from 60s up to now, from almost 3 billion to 7.3 billion. And we are actually, my generation, the first generation in the history of human development to have seen more than doubling the population in its life. I can tell to my sons and grandsons that, yes, I was the one that was living this particular time where people was doubling and triplicating. And during my life, I was able to see all these changes. So we are in this acceleration and transformation side, as Professor Schelube presented before. Transformation is very fast. At the same time, transformation is not all in quantity, but also in quality. One of the maybe more critical dimensions of population growth is the quality of population. We are more and more urbans than rural people. By 2010, we reached the equilibrium between rural and urbans. From 2010 on, we are more urbans, and by 2050, we will be 80% living in urban systems, only 20% in agricultural areas. And that's a big problem. Who's going to grow our food? Who's going to feed us if everybody's staying in urban areas? That's a really big challenge. But also nature is is disappearing and as facing our pressures. This is the last remaining natural forest we have in the world. You can see the green dots are the only one that are really natural. All the rest has been transformed. More than 40% of the land has been transformed in the last 50 years, only last 50 years, into agriculture for responding to our needs. So we have very few nature that remain around us. That's also another big problem. Problem to the nature itself, of course, to habitats, to our biodiversity, but also a problem to us as well. And deforestation is taking place, and now it's almost constant. Now it's about 30 million hectares per year. Just to give you an example, the Italian forest area is 10 million of hectares, okay? So we have every year more than the Italy forest sites, 1.3 times disappearing. And of course, what it was our richness to some extent in the 60s. I mean, we had about 1.7 hectares per capita, per person, is now going down to 0.7. And not only for the population increase, but also because we increase animal feed demand, for example. And there's also a contribution biofuels in that, reducing land. That's the point where we are today, and things are going worse in the future, of course. And socially, okay, I just briefly mention this famous champagne glass, first the UNDP vision of how the richness is distributed in the world. You can see that the most rich, 20% more rich, they own 82% of the total GDP. That's an imbalance in social system that is also vulnerable, make more vulnerable our society. And of course, not only the question of GDP, but also if you look at other indicators that actually beyond GDP, you see that there is there is a quite non-linear relationship between richness as GDP and social progress. In many countries that we think are rich are not indeed wealth society for the people. And that's another dimension that more and more we should think in consideration. But of course, climate change is really a critical, one of the most critical driving factors of our vulnerabilities. I just want to show these scenarios because they contain a kind of a hidden message. You see all the scenarios between 5 degrees or 2 degrees. And if you look at 2 degree scenarios, this is the old IPCC scenario and the last report, you see that by 2050 we should have 0 emissions or so, and starting from there, we should have negative emission. This concept negative emission is some strange or weird for people. What does it mean, negative emission? It's basically carbon sequestration. So all the scenarios that are below 2 degrees are pointing to carbon sequestration. That can be done in, basically, actually, in two main things. One is engineering, carbon storage, putting geological cavities, and that's one way. Or to use forests, to use soil carbon and whatever to achieve the negative emissions. And this is even more evident. The 1.5 report, last report, the IPCC showing that actually in the previous case, we were about 2 gigatons going to negative emissions. Now we are actually looking at about something can be in the order of even 10 gigatons for negative emissions. That's quite a lot. So now we are going to demand a lot to the land. So my question is, are we able to do that? Are we able really to demand again to the land food, water, biodiversity, but at the same time to help us to reduce greenhouse gas emissions? I think it's a central question. It's really central, because otherwise everything can be solutions in the papers, you know, if you don't consider the real implications of what we are talking about. And of course, plants are very important, producing photosynthesis, and Francesco said before, it's one of the primary source of life. Actually, it's the primary source of life of the planet, without exaggeration, really. Also, like to point that this graph of CO2 concentration is very interesting. You show these swings up and down. That's actually the clear sign that the terrestrial biota is modifying atmospheric concentration, because in the summer it's low CO2, in the winter more high CO2 due to modulation of the photosynthesis. So a clear sign that the biosphere is really very much related to atmosphere itself. But photosynthesis is also the way in which you produce biomass, and we put also carbon in the soil. And to what level these components are also vulnerable to climate change? For example, we know that change in temperature, change in hydrological regimes can actually produce more emission or even other gases. Okay, in the case of N2 is mostly agriculture, but methane, for example, can be mobilized from for example, wet conditions, anaerobic conditions in soils. So what we are doing as humans has very important implication, particularly on our natural resources. You see this is an image of satellites, CO2 concentration, real time measured in a planetary atmosphere. You can see quite nicely that we see the signal of our human natural activities are disturbing. For example, looking at the African Congo River basin, you see this blob in red that is the forest fires associated with deforestation in this particular area, showing the emissions of greenhouse gases due to our deforestation processes, as well as in Amazonian due to seasonal shifts. You see another red blob going on. That's again another sign that we are disturbing the atmosphere through our way to use the natural resources. And of course, if you look at the carbon cycle, you see a positive effect of a terrestrial and ocean role. The emissions on the left panel are 88% for fossil fuels and 12% from deforestation. But at the end, what remains in the atmosphere is only 46% of total emission, because the rest, the other 50 or so, are taken up by forests, 30%, and by oceans, by 24%. That's very interesting, because they don't give us the bill at the end, you know, these guys. They don't give us the bill. They just do, because they are designed to do this, and we don't respect that. Basically, we don't have the necessary respect for this very important activity, because this is a kind of a shield. If we took out this 50%, we will be immediately exposed to a huge climate warming if we, by hypothesis, absurd hypothesis, we don't consider oceans and land. Now we know quite a lot about terrestrial carbon sink, and we can just briefly say that the tropical areas are, of course, potentially uptaking a lot of carbon, but deforestation is releasing a lot of carbon. So if you look at the balance, at the end, the tropical belt is almost zero in terms of carbon sequestration, while if you go in the north, in the Mediterranean, temperate and boreal zones, the uptake of carbon is higher than the release of carbon, so we have positive sink. So that's, we can say, with reasonable certainty. Achieving the 2 degrees target requires that we do quite a lot of things, and there are some ideas and hypotheses, but for example, biomass energy, it's requiring something like to have another 380, 700 million hectares so basically 50% of present cropland to be used for that. It's quite huge for getting all the negative emissions we want. Also, forest-based land mitigation is also included with the new forest, afforestation, something to 300 million of hectares. So again, we have to find this land. It's not easy. Just we have to be concerned about these numbers, because at the end, also, we have uncertainties. We have uncertainties in this land management, and the uncertainties are coming from, of course, from humans as well, land use, how much we want to use more and more our land, but also from droughts, from biotic, insects, diseases, from wildfires. We have examples now every year of big fires. And so we have to manage the carbon sequestration in the light of this uncertainties, and also on climate feedbacks as well, because this is a very classical scheme of temperature increase, and you have maybe more productivity, or CO2 increase also increase possibly productivity, and after you have anyway an increased mobilization of carbon due to high temperatures, and you can respire more, and so you can have a positive feedbacks. For example, more temperature, more respiration of carbon dioxide, and so you increase again more temperature. So that could create a positive feedbacks. For example, the other big uncertainty today is about permafrost, the big areas in the border regions where you have frozen carbon is a huge amount. You can say 1,672 gigatons of carbon. So it's a really huge amount of carbon that could be mobilized if temperature would increase in form of CO2 or form of methane, depends. We could consider this kind of a carbon bomb. That's something that could have to be concerned. And finally, something new is coming out when we look at trees, individual trees, and in many parts of the world, we are observing diebacks triggered by, most of the cases, from climate. So this is quite concerning many places in the world. It seems that it's quite a current kind of picture of triggers. And the declining of trees is very common now. It's becoming an important issue, I would say, global level. This is why we have, I just sorry to show you, but we have invented a nice instrument that we call Tree Talker to monitor trees. I want to show you because it's an exercise we have created with people from 18 years old up to 60 years old. So we have a big team of very mixed age, using IoT, Internet of Things technology, and big data. This is more or less the vision, and every tree is now monitored, and they can tell us the physiology, how much water, how much biomass is growing, and so on and so forth. And so this is more or less the picture of the things. And there are about 500 trees now monitoring this every day, every hour. And this is the idea of the global network, of tree global network we are launching as a future new way to monitor our forest resources. The second part I'm going to finish very briefly is about the food that we touched. I will touch a little bit because there was discussion about the intensity of agriculture and so on. But maybe the problem is not so clear that we don't have also to think linearly, in a way that, okay, we have to produce more because we have to feed more. It's not really that the point, because we have some paradoxes. One is this one, obesity and malnutrition. We have people that eat too much today. We have 1.5 billion of people that is obese, and at the end of the day, they die as the others, that they don't have food, because at the end you have 36 million or 29 million of people. Every year they die or because of malnutrition, or because they eat too much and have diseases. So it's also in our lifestyles, in the way in which we really live also the solution of the future. Second paradox is, it was mentioned before, it was about the diet and the meat diets. For example, China is, as we know, is moving very fast into the meat diet, and also we need more land for that, as well as biofuels. So that's again another question. I mean, are we sure that we're using efficiently? And Francesco was saying that before very nicely. Is agriculture efficient? I mean, we don't have to be scared to use the word efficiency today in terms of agriculture, because this is the time. And the food waste and food losses also today accounting for 40% of agricultural products. And this is another consequence, very important, because we have used water, we have used fertilizer, we have used everything to get this 40% we waste. The waste land, I mean, the equivalent of the land that we waste is about the United States every year. That's of a crop land we waste just as resources. This is just an example of a recent project we are developing in Europe, that we want to engage 5,000 citizens in changing their diets, because the number is quite interesting. 30% of the food chain in Europe, 30% of greenhouse gas emission of Europe is in the entire food chain, okay, from production to processing to distribution and so on. So changing the way in which people eat can be very important, and we want to make an experiment of this kind. And finally, okay, yes, we need to go from linear to circular in our thinking, and the recycling is very important, and reuse and new materials, as it was also mentioned before. Bioeconomy is a very important role. I want to just finish saying that, we also need another probably scientific approach. I think we should more use big data, because we don't know yet really all the complex feedbacks, all all the interactions we have in nature. And I like to say that we have to go from Industry 4.0 to Nature 4.0 at some point, where we really monitor everything we can with the new technologies, with new innovations, and try to use the big data as a way to also interpret the future, understanding more about the complex relations. So I think that's a big challenge for us, but it's a new way to look also at our modeling views, going from more deterministic models to more data-driven models. That's very important. I think this was the last. Thank you.